So continuing on with the 10.1 lesson, we were just talking about how it makes common sense that if I have something like 2 to the x equal to 2 to the 8th, that these two values here and here have to be the same because those two are the same. And so we could write this equation that says x equals 2 and kind of ignore the bases. Well, what happens in a case where the bases aren't the same? We have to go to our math facts, and we know that 81 could be rewritten as 3 to the 4th. And I go to 3 because my base over here is 3. Once those bases are the same, then I can say the exponents are the same. So the real work happens right here because this is a very simple equation. Subtract 1 from both sides, divide by 2. That tells me that that exponent is equal to 3/2. Now, example B here, 4 and 8 don't easily break down to the same base, but I know I can rewrite 4 as a base of 2, 2 squared. Notice the parentheses, that's huge. And I can rewrite 8 as 2 cubed. Notice the parentheses. Now remember that rule, a power to a power means I multiply. So I'm going to multiply 2 times 2x, so I'm going to have 2 to the 4x power is equal to, this is a single number also, so you have to do the distributive property. So I'm going to have 3x minus 3 eventually. So since the 2's are the same here and here, I'm going to go ahead and set the equation of the exponents equal to each other. Distributive property, subtract 3x from both sides, and we find out that x is a -3. So again, the trick is seeing what common base. So you're always going to be looking to put something as 2 to a power, 3 to a power, 5 to a power, 4 to a power. You want to break it down to something simple that they both can be rewritten as. Now, inequalities work the same way. Okay? If b is greater than 1, then b to the x is greater than b to the y if and only if x is greater than y. And the converse is true. If b to the x is less than b to the y, then x has to be less than y. So we have the same procedure, except instead of setting them equal, we use whatever inequality sign. This also holds true for our less than and equal than. So 4 to the 3p minus 1 is greater than 1 over 256. Well, 256 I know is 1 over 4 to the 4th because 256 is 4 to the 4th. If I want to rewrite it as a base of 4, this isn't a base of 4 yet here. I have to use my exponent rule that says a to the negative exponent is 1 over, and remember that that converse allowed that to be true also. So what we're going to do is we're going to rewrite this, since it's 1 over 4 to the 4th, we'll rewrite it as 4 to the negative 4. We're going to use this rule right here, except we're going to go this way. In the past, we've been trying to get rid of negative exponents. Now we are going to put them in. So now I have like bases, which means I can set up the inequality, add 1 to both sides, divide by 3. P has to be something greater than or equal or greater than -1. It can be anything greater than -1. Can't be -1. And you can go ahead and check. You can pick any value greater than -1. For example, 0 would be nice, and make sure your equation works. So let's do a sample one. Write an exponential equation given 2 coordinates. So write an exponential equation for the graph that goes through 0, -2, and -2, -32. So this is our base equation. And remember, we're looking for that initial value, which is the y-intercept, which is right here, and then we need an additional x and y. So we are going to do our first step of substituting into our equation. And remember, this is a. So here's my y. So I have negative 32 is equal to negative 2, negative, oops, 2 times b to the negative 2. So I've substituted in x, y, and a. So the first step is to divide both sides by negative 2. And so I have 16 is equal to b to the negative 2. Now I don't have a negative 2. I can't undo that. So what I can really do is I can kind of flip-flop and transfer that negative. And what happens is I end up with 1 over 16 is equal to b squared. We use a reciprocal process. So if it's negative on the variable, apply it to the other side. I undo squaring with square root, and b is 1/4. So step 2, I need to write the equation. So remember, I'm going to leave y in. I'm going to replace here and here, leave x. So y is equal to negative 2 times 1/4 to the x. And again, I cannot multiply that 1/4 and negative 2 because of order of operations. Exponents come first. And just for review, that value right there tells me this is going to be a decay graph because b is between 0 and 1. So that ends the 10.1 lesson.